All right, so this is something that we learned last time, and I'm taking a recap. Okay, the difference between or how we classify physical quantities into vectors and scalars. Vectors being quantities which have both magnitude and direction, scalars being quantities which only have magnitude. Okay, so this is the first thing that we have discussed, especially for the benefit of students who have just joined in today. Now, next thing we'll see is, so from this point onwards, we are studying about vectors. We are more concerned about vector quantities. We're not scalars, you already know how to deal with. So coming back to vectors. So the first thing we understand is notation. Vectors को हम क्या symbol देते हैं? Symbols used for vectors. So any alphabetical symbol with an arrow on top of this, or so basically this kind of symbol is read as vector E, okay, whereas this kind of symbol is read as scalar E. So to denote that a given quantity is a vector quantity, we put an arrow on top of the alphabetical symbol. Okay. So this on top of any alphabet, it is the vector notation. Whereas if you put a vector in between two bars like this, what we know in mathematics as modulus symbol, in vector algebra, this becomes magnitude of vector E. So for example, we can say that magnitude of a certain force is 50 newtons. So this statement here will be interpreted in this way, that magnitude of the force F is 50 newtons. Okay. But if I say F is equal to 50 newtons, this is a wrong statement. This is incorrect. So ये क्यों incorrect statement है? That is because left hand side is a vector quantity. Right hand side is a scalar quantity. Okay. So we cannot, vector cannot be equated with a scalar. Okay. However, if I say that F is equal to 50 newtons towards east, then this is a correct statement. Because now right hand side has both the magnitude and the direction. Or earlier, like we had said, that the magnitude of the force is 50 newtons. Mod F is equal to 50 newtons. That is an okay statement, okay, because we are equating a scalar quantity. Okay. This is an okay statement, this one, because we are equating the magnitude of the force with 50 newtons. Okay. No, Mayank, to answer your question, okay, the difference between plus 50 and minus 50, that is only if I know beforehand that the force is acting along the x-axis. Okay. But here we are covering a more general situation. There's not just the x-axis. No? The force could be acting along y-axis or anywhere in the x-y plane, or the force could be acting anywhere in 3D. Okay. So that kind of notation, that positive is along the right hand side and negative is along the left hand side, that is only applicable in a one-dimensional system, or in a system where we know that our vectors are acting only along one particular axis. But in general, that is not applicable. Okay. So in general, please understand that the algebraic sign plus or minus will not give us the direction because we are not restricted to one axis. Okay, that is a shorthand notation that is generally used in one-dimensional kinematics. So instead of using vector notation, we use the algebraic sign plus or minus because we know from beforehand कि वहाँ पे एक ही axis है और एक ही direction है जिसके along the quantities like acceleration, velocity, displacement, etc. are happening. So by just using algebraic sign, we can use a shortcut notation for giving the direction. Okay. But in general, we do not use the shortcut notation, especially जहाँ पे हमें पता है कि it is not a one-dimensional motion, or we cannot be sure that it is a one-dimensional system. Okay. All right, good. Okay. So, just for the benefit of students who have just joined in, or students who have taken the first lecture in vectors. So vectors are neither negative or positive. Okay, vectors do not have algebraic sign. Okay, so Ansh, to answer your question, a vector quantity has two things only. It has magnitude and direction. So magnitude of a vector does not have algebraic sign. It's neither positive nor negative. Okay, it is just an amount. Okay, so a given vector does not have any sign. Okay. It has a magnitude and a direction. Okay. So when we say that, what is the sign of this vector, the question on its own does not make sense. Okay, because vector is described by two things. It has a magnitude and it has a direction. Okay, now very soon you'll understand why it cannot be have an algebraic sign. Okay, so hope this is clear and these examples are clear to all of you. This example. Okay, good. Okay. Now next thing, very important. This is where our actual study of vectors starts. So see, the thing is, Harshal, to answer your question, हम कभी ऐसा नहीं लिखते that magnitude of force is plus 50 newtons. Okay. This plus is not required because we already know that the quantity is not having any sign. It's just a magnitude. Okay, so a magnitude is such a quantity which does not have any sign plus or minus. It is just a quantity on its own. Whereas, for example, something like charge is a scalar. It can be 50 microcoulombs, it can be minus 20 microcoulombs, it can be minus 1.6 into 10 raised power minus 19, it can be plus 1.6 into 10 raised power minus 19. So it makes a difference whether the charge is positive or negative. Whereas you cannot have a force which has negative magnitude. You cannot have a force which has positive magnitude. A force can only have a certain amount of magnitude. Okay. So in mathematics, when we don't use a sign, yes, it might be implied that the sign is positive. But in terms of a physical quantity, there is a difference between something which has specifically got positive sign and something which does not have sign. For example, mass does not have sign. So we don't say that mass is plus 20 kg. Okay, because there's no such thing as minus 20 kg either. Okay. We can say that change in mass is plus 20 or minus 20 kg. Yes, we can say that. That the mass of a body was, let's say, 50 kg. Then the change in mass was minus 20 kg. What is the final mass? If the initial mass was so much, then in this case it will be 30 kg. Whereas if this had been plus, then this instead of 30 it would have become 70 kg. So that makes sense. But mass of a body on its own does not have an algebraic sign. It's that kind of scalar quantity which cannot be negative or positive. It's just a certain amount of quantity. But charge, on the other hand, you can see charge is a quantity which can be positive or negative. So when it comes to scalars, scalars can be quantities which either have algebraic sign or do not have algebraic sign. But when it comes to vectors, the magnitude of a vector does not have an algebraic sign. Okay? It's just a quantity. So I shall hope this point is clear with the examples. Okay, very good. Okay, so now let's come to representation of vectors. So we saw last time also that geometrically we can represent a vector in this way. So geometrical representation of vectors, okay, is that we use an actual arrow. We draw an arrow to represent a given vector. So vector or vectors are represented by arrows which are drawn such that the length of the arrow, this thing represents the magnitude, and the direction of the arrow is along the direction of the vector. Okay. So for example, if I have two vectors which are drawn like this, one vector A is like this over here, and another vector B is suppose drawn like this. So we can see what is the relationship between A and B. Yes, very good. We can see that first of all, magnitude of vector B is 2 times magnitude of vector A, because इसका जो length है, this length is like 4 times some unit, because one box is 1 unit, whereas इसका जो length है, this length is 2 times that unit. Okay. So you can see that this is the case. This is 4 times some unit, whereas magnitude of E was 2 times of that. So in second, we can also see that they are in opposite directions. Okay. Because इसका जो arrow है, yes, Sana. So what you can see here is that ये जो vector मैंने draw किया है, E vector, you can see how long is this vector. इसका जो length है, that is 2 boxes long, here to here. You can say this length is equal to, I can say, 2 units, where this is 1 unit. Understood? So that means the magnitude of vector E, whatever it is proportionate to two units. Understood the point, Sana, beta? Whereas in the same diagram, you can see the vector arrow drawn for B, this one. इसको मैंने how long I have drawn this? I have drawn this 4 boxes long. That means इसको मैंने कितना magnitude दिया है? 4 times that same unit. Whereas A is 2 times that same unit. That means the magnitude of B is what? It is double of A. And we can also see that A's arrow is pointing along the positive x direction. B's arrow is pointing along the negative x direction. That means they are in opposite direction. Okay, understood. So that is how we use arrows to represent vectors. So we draw the arrows in such a way that it covers both the things. Okay, so the point is, any representation of a vector used for a vector must define two things. It must define the magnitude of the vector, and it must define the direction. Okay. That is why when we said that F is equal to 50 newtons, this is incorrect, because it gives you information about magnitude, but it does not give you information about direction. But when we said that F is equal to 50 newtons towards east, it's a correct representation, because both the things, magnitude and direction, are given. So like that, what is now an easier way of representing the vector? Instead of इतने बड़े words में बोलेंगे, इतना बड़ा statement देंगे that the direction is in such a way geographically, or the direction is vertical, or whatever like that. Easier than that for us, especially to do algebra also, we will see next, is that instead of giving words for the direction, we just represent the direction with the direction of an arrow. Okay. So that method, where instead of specifying direction by words, we just represent the direction by drawing an arrow. We make use of geometry. That representation is called the geometrical representation of vectors. And in such a representation, हम vector को कैसे define करते हैं या कैसे represent करते हैं? By drawing a specific arrow. Now an arrow here is such that इसके दो properties हैं. It has a specific length. It's like a line segment with an arrowhead drawn on top of it. So line segment always has a specific length. So like that, the arrow also has a specific length. And of course, the arrow has this thing which is called the arrowhead. The thing on top of it is called the arrowhead. So arrowhead जिस भी direction में point कर रहा है, वो direction मेरे vector का direction बन जाता है. Okay, so that is how ये arrow के दो properties है, length and direction. वो vector के दो properties को describe कर रहे हैं. The length is representing the magnitude of the vector, and the direction of the arrowhead is showing us the direction in which the vector is acting. Okay, so let us look at another example. Suppose in our system, we have defined our coordinate axis such that this represents east, this represents north, this represents south, and this represents west. Okay. Now suppose excuse me, A is a vector which is drawn in such a way that this angle is 30 degrees. Okay. So A represents a force, let's say, of 10 newtons magnitude acting along a direction which is 30 degrees north of east. Okay. Now what we want to do next in this is that in the same figure, draw approximately a force of 20 newtons acting towards south, and a force of 10 newtons acting towards 45 degrees north of west. Okay. So let's do this as a quick exercise. So we are given like a reference diagram. Reference diagram में क्या है? एक force A इस तरीके से drawn है, which is described in the geographical plane or the north, south, east, west plane as being a force of 10 newtons magnitude, but acting in the direction 30 degrees north of east. So 30 degrees north of east का मतलब क्या है? This is your east direction. This is your north direction. So from east, you are turning towards north by 30 degrees. So if this angle is 30 degrees, this is this particular direction. It is 30 degrees north from east or north of east. So that is how we are representing the vector E. So now given this reference of vector E, we have to draw two other vectors. We have to draw the vector B and we have to draw the vector C. So just try this out in your notebook yourself. I will put up the diagram in a second. Okay. So this is just to give you a bit of practice in how to draw the vector arrows. Remember, we have to draw the vector arrows approximately. So you don't have to sit and with a protractor and a with a scale and a divider and all that. Itna detail mein nahi karna hai. We just draw approximately so that at an approximate level our diagram represents the given information. So I don't expect you to draw an exact to the scale diagram. It is just for representation purpose. So what we will do here is that given that our force E was like this, so I'm now just using freehand drawing so that you understand the same. ये अगर 10 newtons है in magnitude, and its direction is like this, 30 degrees east of north. Now let's talk about the force B, how that should look. The force B should act southwards and it should be 20 newtons. So it should be approximately double in length. ये जो भी length है, इसका approximately double होना चाहिए. So I'll just make an approximate diagram. It should be something like this, so that you can see that this is double in length of this, but this is also acting towards south. Okay. And similarly, the force C should be again 10 newtons, but acting towards north of west by 45 degrees. Okay. So now C should have the same kind of length as A, so approximately, but the direction is different. C is approximately in this kind of direction. Again 10 newtons, but this angle is now 45 degrees. Or that's the same thing as saying this angle is 45. Okay. So 45 degrees north of west is the same as 45 degrees west of north. Okay. Just as 30 degrees north of east is the same as 60 degrees east of north. Because this angle is 60. So this is the diagram that I expect from you. Freehand drawing, you can just do something like this. Okay. So let me make a more accurate diagram, but it's the same thing. So ये अगर 10 newtons है towards this, okay, then the vector B should be. Now the thing is, we don't have to draw B here. We can draw B somewhere else also. It doesn't make any difference. We can also draw this here. Okay. These arrows that we draw, they are free arrows. They can be drawn anywhere. And similarly, the vector C can be drawn anywhere. But it's just that it should be accurate in terms of the direction of the arrow and in terms of the length of the arrow. So here, this should be 45 degrees. You understand that ये north है, ये west है. So you can see that C is a force of 10 newtons acting along 45 degrees north of west. Similarly, you can see that B is a force of 20 newtons acting towards south, just as A was a force of 10 newtons acting at 30 degrees north of east. Yes, so the thing is, when it is 45 degrees north of west, we can just write it as northwest, because it is bisecting that northwest ka 90 degrees. Okay, but if it is some other angle like 30 degrees or 60 degrees or something, you have to specify exactly. Okay, people, so hope this example is clear to all of you. Okay, now let us come to our first vector operation using this. Actually, before that, one more thing. Suppose we have something like this now. Another thing we can do, once we have drawn vector arrows, we can find the angle between two vectors using that diagram. So try this out, people. Draw the two vectors as arrows as described in this, and tell me what is the angle between vector A and B. If the vectors are specified in words like this, that this one is 50 meters at 60 degrees north of west and B is 40 meters at 30 degrees south of east, so उससे मैं angle कैसे निकालूंगा between the two vectors and how much will that angle be? Very good, that's correct, Kshitij. नहीं, displacement का क्या definition होता है सागर? Displacement is just the line from initial to final point. Okay, so displacement just means that. Okay, so here you can see that one particular vector is acting at 60 degrees north of west. So that would be by vector E, which is of magnitude 50 meters. Yes. This angle here, this is my west wala direction, this is my north west. So this angle would be 60 degrees. Now similarly, where is the vector B lying? It is lying along the direction which is 30 degrees south of east. So that one is lying over here. Correct, Mank, correct. 30 degrees south of, but this is a shorter arrow actually because it's only 40 newtons in magnitude. So anyhow, so this will look something like this. It is 40 meters in length, but it is like this. So everybody is correct with the directions. Yes. Yash, correct answer. Mayank, correct answer. Aryan, correct answer. So now you can see the angle between the two vectors that I want, that is this angle. I can say this, or I can also say this. Okay. But it's easier to say this one. If that one is theta, then this is 360 minus theta. Okay. You can see over here that theta is 30 plus 90 plus 30. Okay. Or theta is 150 degrees. So the angle between A and B is equal to 150 degrees. Okay. Or it is also 210 degrees. But generally we specify the smaller of the two angles. When we just talk about the angle between the two vectors, we say like this. If I want to say very specifically, I can say that more specifically, B is at clockwise angle. 150 degrees with respect to A. And that is the same as anti-clockwise. (210 degrees with respect to, because from A's direction, if I go clockwise by 150 degrees, I reach B's direction. Or if I go anti-clockwise by 210 degrees, I reach B's direction. No, but usually we don't express in so much detail. We just express like this. This is more than enough. Okay, is this clear, people? Oh, very good. So once this is clear, now we come to our first vector operation. So now we are coming to the algebra of vectors. Or vector operations. So the first we'll see is the addition of two vectors. Then we'll see more number of vectors. And this method is called the triangle law of vector addition. This is one of the first and fundamental things in vectors algebra. नहीं Ganesh, the point is कि we are talking about the angle between vector A and B. Okay. In that previous question, we are only interested in what was the angle between A and B. Okay. So that is why you can see that one arrow, that is A's arrow, with respect to the other arrow, B's arrow, is at what angle? That is this theta. So ये theta कितना है? Now this theta, for this theta we just saw that this angle was 60. That means this angle was 30. And then this angle is 90. And then it was given to us that these direction, this angle was 30. Okay. So this total angle, ये वाला angle कितना हो गया? This full angle, this is my theta. So that's how this theta is converted. Is it clear, Ganesh? Okay. So now let's come to triangle law of vector addition. So we will first understand this with, if both the vectors are not joined. Okay. So supposing, let's understand this with another example. Supposing I give you one vector which is like this, where this angle is 30, and I give you another vector which is like this, where obviously you can see that this angle is 45 degrees, okay? And this is vector V and this is vector E. Now I ask you the same thing, find the angle between A and B. So here what I'll do is, remember these arrows are movable. So I will move these to a common this thing. Okay, so I will draw the same arrow now here, let's say. And then I'll draw this same arrow from the same point. Correct. Good, that's correct. Okay. So I'll just pick these two vectors up and draw them from this common place. So I can now see that this angle is 45 degrees. Very good, that's correct. And this angle is 30 degrees. So the angle between these two, this angle, becomes how much? It becomes 180 minus, correct. Yes, so it becomes 105 degrees. Okay. Yeah, so Mayank, Umar, Ansh, Aryan, Yash, you all got the correct answer. But Kshitij, hope this point is clear. If the vectors are drawn separately like this, we can redraw them from some common origin. So these vector arrows are movable. We can always move them from one point to another, such that we don't change the direction or the magnitude of this. Okay. So Kshitij, is this point clear to you? कि अगर vectors ऐसे separately drawn है, so then how to find the angle between them? So if we are not able to directly see from the diagram, we can always redraw them such that we draw them from some common origin point, and then we can calculate the angle. Okay, that is. Okay, now coming back to addition of two vectors. So given the magnitudes and directions of vectors A and B. Okay. Now assume A and B are in same units. So what I mean by same units, that means they are the same physical quantity expressed in the same unit. So now we subtracted because see ना, ये angle निकालना था ना. Now this total angle is how much? एक straight line है ना. So this whole thing is 180 degrees. This whole thing here, this is 180 degrees. So that is why theta is 180 minus 45 minus 30. Is it clear, beta? Yeah. Okay. Don't worry. You will do so much practice in these things. You will get used to this. Okay. Now the thing is that coming back to addition of two vectors. Now all of you pay attention on the addition part. You will understand. Okay. So we always understand that addition is only possible when vectors are in this, or quantities are in same units. Man, if the two are force and one value is in gram per second square, gram meter per second square, then we have to convert. The thing is that suppose E is force in newtons, okay, and B is given to us as force, suppose in dynes. So what we'll have to do is we'll have to convert to newtons, okay, and then only we can add A plus B. Okay, understood? So quantities can be added only, two vectors can be added only when they are expressed in the same unit. So here, since we are more concerned with the mathematics part, we won't worry about these units. We'll just assume that they are given in the same units. Okay. Okay. So given the magnitudes and directions of A and B, and the magnitude are in the same units, okay, how to find the sum? So suppose vector E is represented by this particular arrow, okay, and vector B is represented by this particular arrow. Okay, such that you can see the angle between A and B. So given that we know that magnitude of E is capital A, we are just using the symbol scalar A to represent the magnitude of A. The magnitude of B is capital B. So that's also known to us. And theta is known to us, where theta is the angle between vector E and B. Now we want to find E plus B. We want to find this. Okay. So in this diagram, you would see, okay, just bringing this closer here. What would be the angle between vectors A and B? So you can see कि A का direction ये है और B का direction ये है. So this angle is the theta that I'm talking about. This is the angle between the vectors A and B. Okay. So now how would we find the sum of A and B? That is the question over here. Okay. So the thing is, you just think of an operation where A and B are displacements. Okay. So suppose A and B are displacements, okay, in same unit. Then what is the meaning of a displacement? Okay. So what is a displacement? It is initial to final point. Okay. So इसका मतलब क्या है? That suppose if my displacement is just equal to E, okay, so that means whatever my vector arrow is, this is the line joining, or this is the arrow joining whatever my initial position was to whatever my final position is, where I is my initial position or my initial location and F is my final position. Okay. So that is the meaning of the displacement vector. Similarly, if my displacement was just equal to B. Okay. Then what that means is कि B vector जो भी है वो किसको join कर रहा है? That is joining whatever my initial position was before making the displacement to whatever my final position is after making the displacement. Okay. So now if I say that if my net displacement equals to A plus B, so इसका meaning क्या है? Let's try to understand this. Okay. So the individual displacement A is drawn by this arrow. Okay. The individual displacement B is, let's say, drawn by this arrow. They can be drawn anywhere, as I said. So ये arrow है, such that इनके बीच angle कितना है? थीटा है. ये angle कितना है? ये थीटा है. Okay. So what is this thing? How will you calculate this? So let us say that this is the initial point from which I am starting. Okay. So what I am doing in the operation A plus B. Now I am doing the operation A plus B. तो मुझे क्या करना चाहिए? मेरे initial point से I should make a displacement of A. Okay. So I should pick up this arrow. Okay, Veer, I'll come back to your question. Just pay attention here. This is a very important part we're discussing. So ये arrow मैं कहाँ से draw करूँगा? ये वाले initial point से draw करूँगा. So assuming that I've taken the same exact arrow and I've reached here. So I have reached the end of displacement A. But is this my final position? No, because after this I'm also making a displacement of B. So next मुझे क्या करना है? ये वाला displacement करना है. The displacement B, I have to make exactly that displacement. But कहाँ से करना है? Not from this initial position. From the position I finished, from the position I've reached after finishing the displacement of E. So after completing A, मैं कहाँ पहुँच गया हूँ? यहाँ पे पहुँच गया हूँ. यहाँ से मुझे क्या displacement करना है? B का displacement. So I will draw that arrow B from this point. So in other words, to do the operation A plus B, what we will do is we will draw the vector A followed by the vector B, which is starting from A's head. So we will draw the vector B such that B starts from A's head, and then wherever I reach, that becomes my final position. So now what is the net displacement, which we are calling A plus B? The net displacement as a definition वो क्या होता है? It is the straight line from the initial to final position. As you can see, the third side of this triangle is becoming my resultant or sum of A plus B. And this triangle is drawn in such a way that the exterior angle between A and B, that exterior angle is the angle between the two vectors. And that is why this is called the triangle law of vector addition, because we are constructing a vector triangle. Okay. So let us write down this whole thing in words first. Okay. So for the operation A plus B, okay, vectors A and B are drawn successively. Okay. That means B is drawn from the head of the vector B. Okay. So for any vector, this point here is called the head. Okay. And this point here is called the tail. Sometimes we use these terms, head and tail of a vector. So जो arrow head or is sometimes also called the arrowhead. Okay. So B is drawn from the head of A to form the two adjacent sides of a triangle. So now what happens is the third side, that is from the tail of vector E to the head of vector B, ये वाला side. So back in the diagram, this third side is from where to where? It is from the tail of vector A to the head of vector B. This point here, this is the tail of this vector A, and this point here, this is the head of this vector B. So third side मेरा कहाँ है? It is from the tail of A to the head of B. Okay. So that becomes, so this third side becomes sum. Okay. Or we also use the term resultant. E plus B. So sometimes we also use the term capital R to represent the resultant of A. So this is the resultant sum of vectors. Okay. So just make a note of this diagram and please ask me if there's any doubt about how to draw the vector triangle given these two vectors. Okay. So let's start from the beginning. Okay. So let's start from here. So let's understand what is the meaning of displacement in terms of just A and B. Then we will come to the resultant displacement or the sum of A and B. So first, just make sure you understand this diagram. Have you noted the part before this, the heading and everything? Have you noted this part? If not, then just do this also. Okay. So now what is the easiest way to understand what we mean by sum of two vectors? Just imagine the two vectors I'm talking about are individual displacements. So अगर my displacement अकेले A है, so that means my initial to final point is this arrow. If my displacement is single displacement of B or alone it is B, then it is this arrow. But what if my displacement is A plus B? That means successively, one after the other, I made two displacements A and B. So that is becoming this. So this is what we mean by the statement of triangle law. Okay. Now, of course, triangle law will also give us a formula how to calculate this third side of the triangle. Okay. So far, we have just drawn the vector triangle. So this triangle that we have drawn, it is called the vector triangle representing E plus B or the sum of A and B. This one here, this is called that thing, the vector triangle. Okay. So just note this down properly. Okay, so this is clear. Alright, so let's try to understand this with some specific examples now. E is a displacement of 120 meters at 30 degrees north of east. Okay. B is a displacement of 160 meters at 60 degrees north of west. So find the magnitude of A plus B. In fact, do one thing first. Before finding the magnitude, draw vector arrows to represent A and B. Find the magnitude of A plus B from the vector triangle of vector A and B. Okay, just try this out, people. Okay, so let's understand this diagram. Yes, that's correct, Kshitij. So suppose this is my, yes, that's correct, Mike. So this is my north, south, east, west axis. So in this diagram, my vector E will be like this. It is at 30 degrees north of east and its magnitude is 120 meters. Whereas my vector B, वो कैसा होगा? ऐसा होगा. Yes, Sagar, that is correct. Where this angle is 60 degrees. Okay. So you can also see that the angle between A and B, ये angle कितना हो जाएगा? This will become 90 degrees. Aryan, that is correct. Good. So all of you understood that you will be getting a right angle triangle. Okay. So now so this is the first part. I have drawn the vector arrows. Okay. Now the second part, I have to convert this into a vector triangle. So I'm doing the operation of E plus B. So I will first draw the vector E. So like this, let's say. It had a magnitude of 120 meters. Now in comparison to this, from the head of A, I'll have to draw the B. So that will be at what kind of situation? That will be at 90 degrees to this. So A के direction के respect में B का direction क्या है? It is perpendicular. So in respect of A's direction, which is this, now this is drawn at what angle? 90 degrees. And this is my vector B. इसका की magnitude कितना है? 160 meters. So now where is my resultant sum? It is this vector. It is the vector from the tail of A to the head of B. So now using Pythagoras theorem, we can see that magnitude of A plus B in this case will become square root of 120 square plus 160 square. So you can take 40 common. So 200 meters. Okay. So this will be my magnitude of A plus B. So what we can also see from this is that if we are dealing with perpendicular vectors, then the resultant's magnitude becomes root of A square plus B square. Yes, they are equal. Rishad, to answer your question, yes, vector addition is what we call commutative. So A plus B is equal to B plus A. So what we are also understanding from this is that if A and B are perpendicular vectors, okay, then of course we have mod of A plus B, or magnitude of A plus B becomes square root of E square plus B square. Alright, so hope this question is clear to all of you. Okay, next thing we will see is a more general kind of formula. So we will see the general formula for triangle law of vector addition. So what we see here is that given two vectors, suppose this is one vector E, is lying along my x-axis. This is another vector B, which is at some kind of angle theta to it. So magnitude of vector E, which we denote with a simple symbol capital A, is a known quantity. Magnitude of vector B is a known quantity. The angle theta is known. Now, how to find out magnitude of A plus B? How to calculate this? Okay. So first of all, in this diagram, where is A plus B lying? It is the vector from the tail of A to the head of B. So that is this vector. So now the question becomes कि हम इसको कैसे calculate करेंगे? How we will calculate this particular quantity? So for that we use trigonometry and Pythagoras theorem alternately. And how we do that is like this. So suppose we drop a perpendicular from this onto this line. Okay. Suppose what we do here is that we extend the line of A and drop a perpendicular from B onto that. This is not some other vector, it's just a guideline to suppose we do this over here. Okay. And now in this, we denote this side as X and this side as Y. These are perpendicular. Okay. So first of all, we will investigate what is the value of X and Y in this diagram. So X and Y हम calculate करेंगे. So X and Y कैसे calculate करेंगे? By considering this right angle triangle. Which one? जिसका hypotenuse क्या है? B है. So in this diagram you can see that this side is B. So this is the vector B. So इसका magnitude कितना है? It's just the magnitude of B. Okay. This is Y, this is X. Most importantly, this angle is how much? Theta. So for this triangle now, we use trigonometry. So you can see that base upon hypotenuse is cos theta and perpendicular upon hypotenuse is sin theta. So we can calculate the value of X as B cos theta and the value of Y as B sin theta. So in the above triangle now, we have calculated the values of X and Y. Now next thing मुझे क्या करना है? I have to calculate this side. So for that I will consider the larger triangle, the larger right angle triangle. So coming back, the larger right angle triangle, you can see that this side is what we are trying to calculate. ये side the magnitude a plus b, but that will now express as this was a vector e. So that means this length from here to here is how much? This is the magnitude of the vector e. Whereas this was y and this was x. And of course, yes, there is the vector b joining these two, but we are now more concerned with a large right angle triangle. So looking at this whole triangle, for this right angle triangle, you can see the hypotenuse is square root of the base square plus the perpendicular square. Okay. So ये क्या हो जा रहा है? Now x क्या था वहाँ से? X was b cos theta and y was how much? B sin theta. So we will calculate this value using this formula. So we will expand this also further algebraically, but first just understand the steps up to here. Okay, man. So just make a note of this part first. Yes, Yash, that is correct. When we expand that whole thing, it will reduce to what we have just written. Root of a square plus b square plus 2ab cos theta. Okay. So hope you're all clear up to this formula. Now we expand this. This becomes square root of square root of e square plus 2ab cos theta plus b square cos square theta plus b square sin square theta. So now you use the identity that cos square theta plus sin square theta is equal to 1 or unity. Okay, so this just becomes the root of you take the b square term common, you can see that this coefficient is this. So that becomes unity, and we finally get this relationship that magnitude of a plus b is equal to square root of a square plus b square plus 2ab cos. So this becomes the so-called formula of the triangle. So this is something that we can now directly use whenever we have a numerical problem जिसमें कि दोनों vectors के magnitudes दिए हुए हैं and we have to find out the resultant's magnitude, and of course the angle has to be given, theta has to be known. Yes, it will work. Okay. It will work for any range of theta between 0 and 180 degrees. So theta can be anything from 0 to 180 degrees because it's the direct, it is the angle between two arrows. So it can be, maximum can be 180 if they are opposite each other, and minimum can be 0 if they are parallel. So naturally you can see here that if, for example, theta is 0, then cos 0 is 1. So this term becomes root of a square plus b square plus 2ab. So that just becomes a plus b. If theta is 90 degrees, for example, then cos 90 you know is 0. So it just becomes root of a square plus b square, which we've already seen. But now we can calculate for any general kind of value also. So let's look at an example. Suppose magnitude of A is equal to 10 units. Magnitude of B is equal to 30 root 2 units. And theta, that is the angle between the vectors A and B, that angle theta is equal to 45 degrees. So you want to find out the magnitude of the resultant. So here what we can do is we can directly apply this formula. We don't even need to construct any triangle and all that. We can directly apply this formula and see what we will get. Yes, that's correct. Yes, Sagar and Mayank, your answers are correct. So all you have to do here is substitute this in the formula. So magnitude of A plus B, just use this formula. Correct. Rishabh, Guranj, Kshitij, all correct. Ansh, correct. So 2AB cos theta. So cos 45, you know, is 1 by root. So as you can see, this becomes becomes 50. So this is the direct formula based approach that you can take in a question like this. If you were to construct the vector triangle, you would realize that suppose ESI for any vector, whether it is displacement or it is force or whatever it is, so this are the resultant of A and B would be this vector. So here if we drop this perpendicular, we can see this side is 30 and this side is 30. So you can see that this whole base, this is 40 and this perpendicular is 30. So we can also see that magnitude of A plus B so that's another way of doing the same thing. Now the other thing is, in these type of problems, we also want to calculate the direction of the resultant vector A plus B. The direction of the resultant A plus B. So how do we do that? So come back to the vector diagram and you will see that the resultant of A plus B was this. where vector E was, let's say, like this, and vector B in the same diagram. Now, so far I am drawing triangles where the exterior angle is active, the interior angle is obtuse. We will switch to other type of diagram also, don't worry. Okay. But in the meantime, we've also seen that so this side was x, this side was y, and x was b cos theta and y was b sin theta. Of course, this was a. Okay. Now for direction, we also need to calculate this angle alpha. So that is given by the angle alpha, which is the angle of the resultant, that is A plus B, with respect to the vector E. So how we'll calculate that? Now look at this larger right angle triangle. In that, tan alpha is equal to y upon E plus x. Again, apply trigonometry to the larger right angle triangle. This whole, so apply trigonometry to this larger right angle triangle. You can see that tan of this angle is perpendicular upon base. So perpendicular upon base kitna ho raha hai? Y upon A plus x. So it is now further. We get this. So this gives us the direction. So collectively, we have the two formula, that magnitude of A plus B is equal to root of A square plus B square plus 2AB cos theta, and tan alpha is equal to B sin theta upon A plus B cos theta. So collectively, these two formulae, they are called the triangle law of vector addition. So this gives us the magnitude, this gives us the direction. Just make a note of this, people. Wait a second, I'm minimizing. No, triangle law can be applied to any two vectors, yes, as long as the two vectors are expressed in same units. So we can apply triangle law to add two forces in newtons, two displacements in kilometers, or two displacements in meters, or two momentum vectors in kilogram meters per second. As long as A and B are any two vectors expressed in the same units, we can apply triangle law. Okay, the example I took to explain to you the logic of triangle law, that example was displacement, but इसको हम कोई भी दो वेक्टर्स को ऐड करने के लिए यूज कर सकते हैं, प्रोवाइडेड दोनों वेक्टर्स के यूनिट्स क्या होने चाहिए, आइडेंटिकल होने चाहिए. Alpha is just a symbol, beta. अल्फा की जगह हम कोई और भी सिंबल यूज कर सकते हैं, बीटा, गामा, इट डजंट मैटर, बट हमें अल्फा निकालना क्यों था? बिकॉज वी वांटेड टू फाइंड आउट द डायरेक्शन ऑफ द रिजल्टेंट वेक्टर. So हम डायरेक्शन को कैसे एक्सप्रेस करेंगे? यूजिंग सम काइंड ऑफ एंगल. So the symbol I use for the angle is alpha. The standard symbol we use generally is alpha, but that's not the point. Just like theta is the standard symbol used for the angle between A and B, similarly alpha is the standard symbol that we're using for the angle between the resultant and the vector E. So that's just a point of nomenclature. Okay, let's look at an example where we make use of this whole formula now. So suppose vector E has the same magnitude as vector B, and that is equal to 10 units, and the angle between them is 60 degrees. This is the angle between vectors A and B. So you have to find magnitude of A plus B and the angle of the resultant A plus B with respect to the vector E. E के respect में ये जो resultant है, how much angle that makes. Just work this out quickly. So you have to just use the formula which you can see above. Okay, so Guransh, your answer is correct. It should be square root of 300 or 10 root 3. Okay, so people should be getting this answer. I'll explain the calculation also, but this should be coming out to be 10 root 3 units. And this should be coming out to be alpha equal to 30 degrees. Okay. So let's see the simple application of the formula. Don't have to do anything else actually. You can see that magnitude of A plus B is equal to, now just substitute in the formula. Now, cos 60 is half. Because here that cos 60 is half. So that's how you can see you will get this as 10 root 3, square root of 300. So the magnitude of A plus B becomes 10 root 3 units. And also tan alpha is B sin theta upon A plus B cos theta. So make use of this formula here. So 10 sin 60 divided by 10 plus 10 cos 60. So that will become this. So 5 root 3 upon 15. So that is root 3 by 3 or 1 by root 3. Okay. So tan alpha is 1 by root 3 means that alpha is equal to 30 degrees. So this is your final solution of this question. Okay, so just a couple of more things we'll understand before we conclude today. So hope this question is clear to all of you. Now next we'll understand what happens in a situation where theta is an obtuse angle. So the vectors now they look like this. This is the vector E. In comparison, vector B is at an obtuse angle now. Vector B is somewhere here. Suppose we have a situation like this. So always the angle theta is the angle between the two vectors. So that is the exterior angle of the triangle. So how to substitute in the formula or how to find out the third side when something like this happens. So for obtuse angle thetas, we use the formula for theta greater than 90 degrees, less than equal to 180 degrees. That is theta in second quadrant, you can say. Now here I am for the moment just going to give you a formula, but you will be studying this formula in more detail, the derivation of this formula and all in trigonometry also. And by the time we do component algebra of vectors, you will understand the derivation of this formula I am giving also. Okay. Cos theta for such an angle becomes minus of cos 180 degrees minus theta. Okay. And sin theta for such an angle becomes positive of sin 180 minus theta. So for example, cos 150 degrees कितना होगा? So we'll use this formula that cos 150 will be minus of cos 180 degrees minus 150. Okay. So that is minus of cos 30 degrees. So that is minus of root 3 by 2. Okay. And for example, if I want to calculate sine of 150, that will be positive of sine 180 minus 150. So that will be positive of sine 30. So that will be positive half. So that's how I'm getting the result that cos 150 is minus root 3 by 2, whereas sine 150 is half. So just one example of how we use the obtuse angle formula whenever theta is in the range of 90 to 180. So as I told you, don't worry about where this formula has come from right now. Okay, we will discuss its logic when we discuss components in vectors also. Plus in trigonometry and maths, you will be learning more about this. It's called trigonometry in 4 quadrants. Or in maths, sometimes in short form, we call it the ASPC rule. You may or may not have done that in maths yet. Yeah, very good. So if you've already done it, then it's good. The meaning of theta in second quadrant it is like this, that if with respect to x-axis, we draw an angle of theta, so this is theta in first quadrant, because this is quadrant 1. But similarly, theta in second quadrant would be something like this. So this is quadrant 2. So here theta is in second quadrant. ठीक है Sarah, beta, is that clear? Like that we have third and fourth quadrant also. Okay. So let's wind this up with a quick example with an obtuse angle. So this time in our example, again magnitude of A is equal to magnitude of B, equal to 20 units, but the angle between them is 120 degrees. So find magnitude of a plus b and the angle of the vector a plus b with respect to the vector t. Just work this out quickly, people. Just a moment, people. So I've not got the correct answer yet. So let me explain. So यहाँ पे क्या होगा? Magnitude of a plus b. Yes, finally correct answer. Kshitij, Ansh, Mayank, okay. Many others now. So root of a square plus b square plus 2ab cos theta. Now इसमें a will be substituted as 20, b will be substituted as 20, but cos theta will be cos 120. Now cos 120 will become minus of cos 60 degrees. Okay, that is minus of cos 180 minus theta. Using this formula, so it's minus half. So cos theta has to be substituted as minus half. So this becomes 20 square plus 20 square plus 2 into 20 square into minus half. So that just becomes this. Correct. So mod of a plus b becomes 20 in whatever units a and b are. So if a and b are forces in newtons, 20 newtons each, then a plus b is also 20 newtons. Okay. So that's done, and now the angle tan alpha is b sine theta upon a plus b cos theta. In this sine theta is nothing but sine 120, which will become positive of sine 60 for the same reason. So positive of root 3 by 2. So this now becomes 20 into root 3 by 2 divided by 20 plus 20 into minus half. You can see tan alpha will become 10 root 3 upon 20 minus 10. So that's root 3. So that means alpha is equal to 60 degrees. Now we can also see this very easily by actually just drawing the vector triangle. You will see that this particular vector triangle will become an equilateral triangle. So this answer that the resultant is also equal to 20 and the angle is 60 is very obvious from that. So I could have just drawn the triangle geometrically instead of using this. I have understood that if this is the vector A of magnitude 20, then in comparison the vector B in this case should be like this because it's at 120 degrees. So it should be 20, where this angle is 120 degrees. So the resultant here is becoming this. Now you can see that whatever this angle is, this will have to be the same in this case because this side is equal to this and their sum should be 120. So 2 alpha should be equal to 120 degrees. So that means alpha should be 60 degrees, which means that now it's an equilateral triangle. Which means that the magnitude of the resultant or the magnitude of A plus B is equal to the magnitude of A is equal to the magnitude of B is equal to 20 and alpha is equal to 60. In this case, it's a very well-known triangle, the equilateral triangle, so it's also easy to do this geometrically. But generally, it's not easy to solve the geometry of a triangle and come up with the answer. The easier method is the formula of the triangle law, which we have done above. Okay, so that's so Dania, don't worry, we have ended the lecture. Okay. Sorry to keep you late. Okay, so that is the conclusion of today's lecture, and I will be sending you the recording as well as the PDF of my class notes. So you can also I'll send you a set of questions to work out yourself. So that's it for today's lecture, people. Now, particularly students of greenhouse who have joined in, I will send you a video of the first lecture also. Go through that once carefully, and if you have any doubts, etc., message me directly about that. I'll help you out with it. Okay. So that's it for today's class. Thanks for attending, people, and all the best.